just our bread and butter software, the best possible reverse engineering software on the market. It's going to be Geomagic Design X. So this software is peerless. It has combines history-based CAD with 3D scan data processing to tell you the fastest scan to CAD interface, especially when it comes to odd surfaces, or freeform surfaces, things like that. The way this works is you get your scanner, you import your scan data, and then you can create from that scan data a parametric CAD file and then transfer that parametric tree to any of your favorite software. So we got SolidWorks, CATIA, Creo are the main ones, Autodesk, and then we can actually go to some of the CAM softwares, or many of those as well, or analysis softwares directly. So pretty nice. We also have a direct import into CATIA. So we have the best possible geometry translation. All right, again, another, just kind of an image here. This is a project I did a long time ago, I say a number of years ago. I used the Metroscan to grab an entire side-by-side, and we reverse engineered all the external body surfaces as well as the roll cage using Design X. I would not have done this with any other software. It's just, this is the fastest possible solution. A few other nice, points about Design X. So we've got an automated and guided tool sets, which you see here in a video in just a moment. Any point along the way, we can check our CAD accuracy to our scan with the accuracy analyzer. And then at the end of the day, so you can make sure that your CAD file is going to be as accurate as possible. And then once you're all wrapped up, we can do the live transfer tree to your favorite CAD program. Let's say you're using SolidWorks or something like that. So for the second video presentation, this one's a little longer, but it shows a lot of the different tools that I use on a daily basis that are my favorites, and the reason that Design X really pulls ahead of everyone. All right, so as we launch this here, we have the make sure this is going. There we go. Okay. So the way that Design X works is it breaks the mesh into these regions here with the auto segment tool. And these regions are essentially areas on the mesh that the software recognizes or thinks of as common geometry. So we've got freeforms, we've got cylinders, planes. Now it's not geometry, it's just areas on the mesh that the software recognizes. Those let us do our automated solutions. Behind those automated solutions is this very basic tool, the Mesh Sketch. Now I say basic, it's very powerful because it allows you to create a sketch and cut a cross section to trace for each sketch that you do. Because we can't get a 2D cross section on this 3D profile blade, I want to get the full profile. I can expand what's called a silhouette range, which is it's fairly unique for Geomagic. And what that does is it projects the whole profile of that blade to my sketch plane. Now what we're looking at here is basically a 2D version of those 3D regions that you saw, all the different colors, and it segments this cross section up into what it thinks are common areas. And what you can utilize that for is putting geometry on those areas. So here what I've done is I've laid an actual spline across that because it's more of a spline function there. I've laid a spline across that whole line, and what that's done is at that point it's going to convert it to real geometry. So we can utilize any of our sketch tool, our general sketch tools if we want to in here. We can trim up this whole area because I want a full bounded area. Because what I'm looking for is a solid body that I could extrude that is the exact outer profile of that blade. All right, so we can pull these nodes along that. You see everything snaps to that reference polyline. So we can snap everything up to it, make sure we're all nice and accurate. Okay, make everything tangent, and that way we have a really nice blade profile. So what I'm going to do is take that sketch, which is just at this point it's just a regular sketch, just like you would do in any other programs. We're going to extrude that one way and then the other. Okay, and you can see there we get our solid body. Now the next step is to cut. I've already done a surface file or surface in this file for one side of the blade. We're going to show how that works in just a second, how I create that. But we're going to use that surface to cut that blade off. Now here's the accuracy analyzer. You can see here, we can put in any specific tolerance we want over there on the right side, and it'll show us a green color map, show us any areas like that little red area that's flagged, say, hey, this is out. For this demonstration, I'm happy with that. But we'll show how you tune all that deviation out here in just a moment. The Loft Wizard is the tool we're going to use this with. So with the Loft Wizard, you utilize that region, the one we broke up at the beginning, that I already had broken up, and we decide how many segments we want in that region. Okay, I already know because I've done this, but you need 15 segments because this is a fairly complicated, not super wavy, but just it changes a lot from tip to base. And so what we're going to do is we're going to tell it to put a number of sections in there. I always start lower than I think I need, and then I'll adjust from there. Okay, so you can see here it's taken that and it's cut a cross section on that mesh all the way down that blade. And when I turn on Accuracy Analyzer, that gives us a live view of how accurate our CAD surface is to the underlying scan. We got a few areas there that we need to get rid of, and you can adjust. Right here I'm adjusting the number of spline points because it was just way too dense. Each of those segments was pretty dense. You get those down as far as you can, and then now you can drag and drop those cross sections and tune that deviation out. So pretty nice. It's all interactive. So with that Accuracy Analyzer paired with the Loft Wizard, we can accomplish the hardest part of the loft, which is determining where we need those segments to be, because you can really chase your tail if you don't have this option. Putting one, as you can see, putting one segment in one spot may cause like a teeter-totter effect that throws out another one. So this really lets you play around and get your most efficient loft without having too many segments in there. The more segments you get, the more ability, or I guess the more possibility you have of getting ripples and things like that in your surface. But this tool alone is just, this is what makes DesignX my go-to, because when I do reverse engineering projects, it's because I have geometry like this that I have to deal with. And this tool accomplishes the job. It's not even close, the fastest out of everything else. So we can use that new surface to cut that extruded body just like we did the last one. And you can see there what we're left with is our blade profile. So I'm going to use a standard tool. You'd find anything else to round that front leading edge, because those edges on an airfoil need to be rounded. We're going to use a full face fillet, and you can see there it puts a nice round all the way around that profile at the limit that we sketched it. So so that way we make sure that our fillet is not pulling that edge in or out. From there, I'll roll through. I have a few things already done, but I did another loft to make the base of that root, or basically the base of the blade that's going to interface with the hub. And then I use a standard loft tool, making sure my faces are tangent to get the blade to the root. All right, and that's a very efficient way to get that. So I try and close that gap up as much as possible. That way the software doesn't have to do anything crazy. You can always sketch in guide curves and things like that as well, to make sure you have a very nice transition from the blade to the root. So the last thing I want to show, we've got these, up with the Loft Wizard, we have a Sweep Wizard, Mesh Fit Wizard, Extrusion, Revolution, and Pipe Wizard, along with a couple others that are not shown in the main toolbar. The Revolution Wizard is really cool because we can choose the center axis of our hub, and then we can click and select basically the regions that make up the profile of this revolve for the hub. And what the software is going to do is it's going to create, just like with the blade, it's going to create an automatic geometry solution for us. So what I'm doing is I'm selecting all the regions. Basically, if I were to cut a cross section through this hub, I'm going to get that whole profile. Okay, and then when I go to the next stage, it allows me to tweak those with these sliders, the resolution, whether or not I want the small fillets that it sees as sharp edges. I've got a few different options, and when I click my checkbox, what's really cool with any of these is that once I create my part, it doesn't just throw the part in there. Just like with the surface, it creates a, you can see over here in the tree, it creates a sketch and it creates the revolve. So we have a parametric feature from an automatically created geometry. You can always go back and you can edit it afterwards. So it doesn't give you exactly what you want. Being it was automatic, you can edit it from there. So I put a fillet between the revolved hub and the root of the blade, just so we don't have any sort of stress concentration there. And with the fillet tool, we have that automated button, so automatic radius button that'll find the radius, and then you can fine tune it from there and make it more of a standard value. And that wraps up the model of the blade. That's everything that you just saw there was the whole model of that blade. So once we get done, we can check that accuracy analyzer, make sure we're good to go. And then we can transfer this entire tree over to SolidWorks. So that's what I've got on my computer. You can do it to a number of different programs, but I've got SolidWorks, but it works the same way. And so I've sped this process up. This, it basically transfers this line by line. But in the video, you can see here all these segments coming in. So we've got the line segments, we got the extrudes, we got the loft, and this is going to build our model in SolidWorks. And that way we can save it as a parametric SolidWorks model. Very cool. So if you got a part catalog that needs that sort of thing, we can obviously save it out as an IGES or STEP or Parasolid and just have the solid body. But if your catalog requires you to have that parametric list, we can get you that. If you got an end customer that wants a full parametric SolidWorks file, same thing, you can deliver one. So there we are. That's the model, just like what we got over in DesignX. And that's the full start to finish Geomagic DesignX workflow. So awesome software.